Alright, we're ready for chemical bonding, list dot structures, naming compounds, and writing formulas, part 2. And we still have the same basic teaks. You're going to have to name the compounds, you're going to have to write the formulas, you're going to have to understand or write the electron dot formulas showing how they're bonds. You're going to have to describe metallic bonding and how it makes metals. And you're going to have to predict some molecular structure. Oh, how lovely a picture. Covalent bonding is when they share electron pairs between two atoms and you get a molecule that's produced. Molecules are produced by covalent bonds between atoms. There are some diatomic molecules, before we get really into this, that you're going to need to know. You're going to need to stick them into your brain and keep them there. These are atoms that are elements that when they're in their pure form, they're never by themselves. It's like, girls going to the bathroom at a football game, they never go alone. Hydrogen, oxygen, chlorine, fluorine, bromine, iodine, nitrogen, they are never by themselves when they're in their pure form. They're always bonded to another of their own kind. So we have hydrogen bonded to another hydrogen atom, oxygen bonded to another oxygen, chlorine bonded to another chlorine, and so on. They're called diatomic, two atoms, diatomic molecules. There's a little mnemonic here to help you remember that. It's help our class find its brain now. Hydrogen, oxygen, chlorine, fluorine, iodine, bromine, nitrogen. And when we start writing the reactions out, you're going to have to realize, hey, when I see oxygen and it's all by itself, it's not bonded to any other atom, any type of other element, then you always write it as O2 because there are always two of them bonded together. All right, next thing on there, letter B, is a chemical formula. In the chemical formula, you guys already know about these. They show the numbers and the kinds of atoms in the compounds, and they use the subscripts, and they use the symbols of the elements. Since they're using the symbols, no cursive. Remember that the symbols are written in Latin. We just got really lucky here in the U.S. where we use our language, our written language is based on the Latin. So the symbols are the same for us. No cursive in the Latin, so the symbols must be printed. First letters capitalized, second letters never capitalized. Make sure that you write the symbols properly. Non-polar covalent compound means it's pure covalent, absolutely perfectly, beautifully shared. We're going to pretend there are no gray areas here. There's a nice, even distribution of electrons. It's balanced out. It's nice and even. Polar covalent compounds, on the other hand, it's where the electrons, it's not equal, the electrons aren't equally shared. So there's an unequal attraction for the electrons that are supposed to be shared, which means one end of the molecule is slightly positive and one end of the molecule is slightly negative. Oh, look, you see the North Pole. I wonder why. There's a picture of a little North Pole sign on there. Remember still that the octet rule applies. The magic number is 8. It applies the vast majority of the time. Atoms become stable when they have an octet, a number 8 valence electrons in the outside orbit or energy level. There are a few that are less than that, so hydrogen, lithium, beryllium, boron, those guys are so tiny that they are stable when their outside orbit is full, and for the most part, that's going to be their first orbit or their first energy level. And remember, the first one's going to only hold 2 electrons. Now, again, there's some gray areas here, but we're first-year chemistry. We don't need to worry too much about the gray areas. Letter B, more than an octet. There's some that are just little psychos in there. And so you can have sulfur with fluorine 6, so SF6, So there's some strange gray areas. And then you have a few that have some odd numbers of electrons to form a compound, and they're just strange. You're not going to have to worry about the oddballs. You have to worry about the basics. All right. There are some certain characteristics of covalent compounds, and if you're homebound, then you can do the lab that's in your packet because you have aluminum foil, you have wax like a candle, and you have salt, so you can do this lab. There are certain characteristics of covalent compounds that you need to look for and you need to realize. For the most part, compared to ionically bonded substances and metallically bonded substances, covalent compounds have a lower melting point and boiling point. Most of these are rubbery or powdery, rubbery or powdery, I can't say it now. Rubbery or powdery solid, or they're typically liquids or gases. They don't conduct electricity. the polar molecules dissolve in other polar molecules. So remember, we have covalent compounds that are polar, where they kind of, it's a lopsided sharing of the electrons. They will dissolve in other polar compounds. And if you notice down at the bottom of the PowerPoint slide, it says like dissolves like. That's huge. Like dissolves like. Polar stuff dissolves in polar stuff. Non-polar stuff dissolves in non-polar stuff. All right? I'll bring that up again when we talk about the next type of bonding, which is ionic. So like dissolves like. Keep that in your little brain there, okay? All right. We can have a single bond where just one pair of electrons are shared, and that's like in water, H2O. And they usually symbolize it with a little line, a little structural line there. So one line equals 2 pair of electrons, and we typically have the short bond length. Then we can have a double bond, and a double bond means you share 2 pair of electrons, and that should be between. I don't know how that C got in that word between there. So you're sharing 2 pairs of electrons between atoms. It's a shorter bond length, and an example would be carbon dioxide. And then if we have single bonds and double bonds, I bet we also have triple bonds, where you have 3 pairs of electrons that are shared between the atoms. This is the shortest bond length. Boy, that triple bond, it's a strong bond, it's short between them. An example of that is carbon monoxide. And I think we're ready to move on to PowerPoint number 3. Oh, we are.